Hello and welcome to my talk, JUnit5 Custom Test Engines. My name is Sven Ruppert and I'm developer advocate at JFrog, and they're specialized for DevSecOps. Today we want to see how to create your own test engine for JUnit5. That means in the beginning we will have a short introduction about the possibilities of the default test engine from JUnit5. After this I will show you how to test your test engine so that you are able to test your own test engine later, and how to start a custom test engine. After this, we will have a short overview about the basic structure of test engines, and then how to define a test so that a developer can write his first test for your custom test engine, then how to execute test plans, and in the end, custom test engines, some ideas and possibilities, what you could do with custom test engines and why this will help you. First of all, I want to have some ideas or some refreshments about what is a test scope and how this is organized in JUnit5. Here, let's see, we have global preparation. These are the yellow bars here in my slides. Means that something should be started or prepared before you start executing your test engine. The next thing is you have preparations just for your single test as well. So for every test, for example, you're ramping up a software container or you're ramping up some demo data or whatever. And then you're executing this test. And in the end, after this test, doesn't matter if it is successful or if it has failed, it should redo or undo all the preparations you have done for the test. And after all tests, or after executing the test plan, the whole test plan, you want to make sure that all resources you allocated in the beginning are deallocated again. So in total, you have some life cycles, and quite often you have to create resources, destroy resources, and all this stuff around the test you want to execute. Talking about this one means that every test will have its own context. The context itself means that you want to share some information between the ramp up phase and the ramp down phase of a JUnit test. For example, you're starting a servlet container, you're running a test, and then you want to destroy exactly this instance of the servlet container. And now we have a challenge. First of all, every context of a test itself should be isolated so that no context is shared between different tests if it is not necessary or you explicitly say you want to share. And this means that you have a context that is going over all tests, for example, over your whole test plan as well. Different borders or scopes could be all tests in one class, all tests in one package, whatever a test scope can be for you. In the end, you're talking about a hierarchy of contexts, so that if something will be stored there, it must be accessible inside the context, but not outside. Not below, maybe, maybe not. It depends on your needs, and maybe not outside or above this context. So the main thing here is that assume that something will happen during the initialization phase. Then basically it's easy to cover, because if something is going wrong, the servlet container, for example, is not started, the test will fail because the resource is just not available. But think about something that will happen during the test deactivation phase. So for example, if you want to remove all stuff from the context to make a space or make it available for the next test. This means that if you have exceptions or if you have something that's going wrong inside your context or inside your context management during the ramp down phase, this could lead to really bad behaviors and wrong test results. So one thing is, a preparation for test must be very fast, because the really important time is the test itself. And all the preparation before and after, or the ramp down phase, is just technical costs. The next thing, it is quite easy if everything is very symmetric. Means for this test I have to ramp down this service, and after this test I have to ramp down it again. So up, test, down. But what would happen if you have it unsymmetric. So if you're ramping down something and then you have to do several tests and then ramping down later. Even this is symmetric if you're really doing it over a bunch of tests that are in the same scope or whatever. But sometimes you have asymmetric things, and this could be a challenge. One question is how to deal with exceptions. For example, you want to ramp down a servlet container, there is an exception, and the servlet container you ramped up is still running. So how to deal with these exceptions? What do you want to do with the test plan? Do you want to fail the whole test plan or just a part of the test plan? So dealing with exceptions is one of the really important things with JUnit test engines. And last but not least, every test can have its own preparation. So the declaration and how to deal with this context and ramping up and ramping down should be in a way that it is dynamic or customizable very easily, but not so that you have to declare again and again the same stuff for the same kind of test. So there is a challenge that you are doing it flexible enough, but not too repetitive. If you have now this single test, then the next question is how to deal with test groups. For example, you have this context and then you have different test groups, and these test groups should it be isolated? Yes, no. And if it is isolated, in which way is this isolated, or do you have the possibility to share information between test groups? Okay, and if you have different test groups and you have the decision done if information could be shared between different test groups, you can think about test engines as the next one that is holding a bunch of tests or a bunch of test groups. So with JUnit5, it's possible to have a bunch of test engines during the same run. So it's not necessary to decide you want to run only one test engine. No, you can have multiple test engines in one test run. How this is done and ramped up, we will see later. But as short recap, we have this single test, a single unit of something must be done with individual preparations. You have this clustered in some kind of groups with shared resources or shared preparations and ramp downs. And then you have different groups you can define, and then you have inside or around these groups or bunch of groups you can have dedicated test engines. This is the main structure that is introduced by JUnit5. Some parts of this was already existing in JUnit4. But if we have this in mind, we have now different possibilities. We have to think in general how to define tests, how to define groups, how to deal with context and preparations, and how to deal with different test engines, because everything together will give you the full power of how to deal with the JUnit5 environment. This graphic I'm showing right now is not from me, it's from, I think it was from the original documentation of JUnit5, but it will show you some very interesting things. One thing is, for example, that you have in JUnit5 the possibility to run the old vintage engine. It means the possibility to run nearly all JUnit4 tests. This means for migration purpose, you can just hold your old JUnit4 test and run them inside JUnit5. This is a good idea because if you have to think about migrating from JUnit4 to JUnit5 or from JUnit4 to your custom test engine in JUnit5, this will give you the possibility to play a little bit with the timeline or with the investment line. So just have it in mind. There are some things that are not really running with JUnit4, but you have to check it for every single JUnit5 subversion because this is changing, and then have that in mind during your plannings. The next thing is the new test engine, the default test engine is called Jupyter, and here we have a very generic, a very broad test engine that fits nearly to 80 or 90% of all needs you have. And it's always a good advice before you're writing your own test engine, just check if you can do the same stuff with the default Jupyter engine, because then you have a managed or maintained test engine already and you don't have to do it by yourself. And then you can go with third-party plugins on top of this platform. So all these test engines are running on top of the platform. And then we have a tiny beast here below. It means this tiny bubble here with IDEs and build tools. First of all, I thought, this is just to mention all this stuff. But if you're looking a little bit more in detail to this tiny thing, you will see that, or if you're analyzing the behavior of these different tools, you will see that the behavior between Maven and Gradle, even if you're running the same JUnit5 version with the same amount of tests, is a little bit different, because there are changes or difference in the way they are managing class paths and the class loading. And this is sometimes not nice, because you have little different behavior, and the same is with Eclipse and IntelliJ and all this stuff. You have slightly different behavior, even if you're using the same source code. And what this means, I will show you on how you can remove this one with your custom engine, custom test engine like this. This I will show you later. Okay, if you're looking at the general purpose weapon here, this general purpose test engine, we have this global preparations, subject of test, we have this context and the global context inside a test group, and it means we have now different things to declare. For example, how to declare test, how to extend or customize the lifecycle as well, and then how to deal with extension context. The JUnit5 intro. If you want to write a test, the only thing that is needed, okay, you need the dependencies for sure, but then you just need the annotation add test. And then you have more or less a functional test. That's it. So to declare a test is just done by adding an annotation. So it's part of the source code itself. If you want to extend the lifecycle, you have different possibilities. And one thing is, or the lifecycle itself, you have inside the documentation the lifecycle and the lifecycle steps well defined, but here check again the documentation for exactly your JUnit5 version, because there are difference in between this tiny version differences. But in general, it's like you have these callbacks. Here in the slides, I'm showing you the before each callback and after each callback. So before every test and after every test. And to customize this one, you just have to create a class. Then think about the lifecycle steps you want to extend or customize, where you want to hook in. And then you're implementing these functional interfaces before each callback, for example, or and after each callback. And then you see inside this method declaration that you will get an extension context. Inside this extension context, you will find all the information you need about the invocation, and this is a place where you're pushing a state so that you can share information between the before each callback and the after each callback. What you definitely never should do is storing something in the test class itself in this instance, because the platform doesn't make sure that you're dealing with the same instance if it is not invoked a few times, and so on and so on. So if you have to share something, go over this context. That's it. To use your extension, you have to go to your class, your test class, and just annotate it with extend with, and then the class declaration. And after this, the lifecycle is activated for exactly this class and all tests inside this class. Okay, the next one is, I have now two extensions. And if I have two extensions, and I'm going to my test class and extending 2 times, for example here with my extension A and my extension B, then both implementations are active to customize this lifecycle. One thing that's very important here is there a difference if you're writing extends with A and then extends with B compared to extends with B and then extends to A? And the answer is yes. So the order matters definitely here. If you're extending first with B and then with A, then you will have the following lifecycle. First, everything before all from B will be done. Then before all from A will be done. After this, before each B, before each R, the test. After each A, after each B, then after all A, and then after all B. So what's done is it goes from the outside to the inside and then reverse to out of the test. That's very good because it solves a lot of challenges we had with JUnit4. Just have it in mind. So the order definitely matters. If you don't want to add so many extensions, you have the possibility to use the extensions annotation. Then you can create a composition of all your extensions, and then you can use this composition of extensions at your test class as well. So what I would do is the tiny extensions are technically extensions, for example, ramp up servlet container, ramping up database and all this stuff, and then just build compositions with more business-like wordings, for example, ramping up environment or whatever, and build this composite annotations. That's it. So, talking a little bit about the context itself, because we need this one later to store or to share information between tests. You will get this instance of extension context, and here you have to deal with stores, and the stores are more or less, a store is nothing different, or it's a hash map. It's a hash map. So the store itself, you're asking the store, please give me the instance of the store with the name ABC. This should be a constant shared in your application so that you don't have refactoring issues. And then you have a hash map with a name or an entity of a hash map, a dedicated entity of a hash map. And then you can just push data in, push data out. It's just a key value store. And here I'm just using a key that I'm declaring like a final, like a final string or as a final string to make sure that I'm using the ID, auto-completion stuff and all this stuff. So I'm putting stuff in my store, I'm executing the test, and after this one I will get exactly the same extension. I'm taking the same store, I'm grabbing out the instance, and then, for example, destroying the servlet container. So before the test, I'm creating the servlet container, pushing it to the context. After the test, I'm grabbing it out and destroying it. That's it. So this is quite easy. So if I want to have my own instance injected, because there's quite easy dependency injection implemented in JUnit5, you can just declare it here, so to say at test, and then you're writing down, or you're writing inside the method signature the classes and variables you need. And now JUnit5 needs to understand this one. For this you have this parameter resolver. This parameter resolver is more or less something that will hook inside the lifecycle automatically. So they are scanning the class path, and then they're activating this parameter resolver. You can do it manually, or you can use this with this auto scanning feature. And you have to implement two methods. One method is a supports param. This is just check if the type that is now inside this method signature is exactly what you want to handle. And then resolve param is just how to create or how to get this instance. And with this, you first get the supports param invoked, and then you say, yes, it is a type I want to handle, or no. And if this is done, the second method will be called later the resolve param. You will get this extension context. So if you know that there's something inside this extension context already shared or stored, you can make use of this one and then just create the instance. Here it's just a new constructor, but you are completely free in technologies you want to use. Okay, now you are able to create on the fly things you are injecting into the test. To activate this one, you can do it on class level or on method level. Here I'm just showing it on method level. I'm extending with this param resolver I just created. And this means for this dedicated method, I have the possibility to get this instance of type demo injected on method level or on class level, and then this is available. Okay. Why I'm talking about this that's already existing? Well, we need all this, for example, to test our own test engines. If I'm writing a test engine, it makes sense to write tests for my test engine to make sure that the implementation is doing exactly what I'm expecting. So we are writing tests for our test engine, means we are using the vintage engine. This is highly recommended because then you have this basic test engine that is validating the behavior of your custom test engine. It's this chicken or egg question. So how to test a test engine? First of all, we need a way to test a new test engine. So how to do this one. And for this, we will just create an existing test engine first. So how to ramp it up, how to test it, and then we will see how to create our own one. For example, I'm creating a demo test class, and here I have 3 tests. One test is just doing nothing. One test, and with this doing nothing means implicitly it is a positive test. The next one, test 2, it's just throwing an exception and explicit a runtime exception with a dedicated message. And the last one is a disable test. To have access to this toolkit, you need this dependency org JUnit platform. And then the artifact ID is JUnit platform test kit for the dedicated version you are using. And don't forget, just put it into scope of type test, so that's not delivered accidentally. So here I have my demo class. I have a positive one, I have one test failing, and I have one test that is disabled. It means in general I have 2 tests started. One test disabled, one positive, and one negative one. If I now start the test engine, here I have my engine test kit. Inside my engine test kit, or with this one, I have a bunch of methods to invoke or to handle this one. They really love the static methods. So I just use the method engine, and I'm using a name for it, the engine ID. What an engine ID is, we will cover a little bit later. And then I define the amount of input class or the amount of tests. You can say just go to this package and take everything, or to the class path and grab everything. But if I want to have a dedicated test for one test engine, it makes sense that I'm just using explicit one test that I want to use as input for my test engine. And here what I'm doing is I'm invoking the selectors method and selecting a class, and here in our case the demo test class itself. Then I'm executing the whole stuff, then I'm grabbing the tests out of it, and then I start analyzing the result. Here what I'm doing is I'm checking the status, and here I'm just checking status.started2. Yes, I have 2 started, the positive one and the failing one. Succeeded 1, yes. Skipped 1, yes, it was this with this disabled one, and then failed 1, this was a runtime exception. What I checked right now is just if the general behavior was okay. So I have here this declare test, and everything happened in the way I thought it should be. After this, I can just go a little bit more detail and check, for example, the failed test a little bit more. Here, just as a recap, the test 2 was throwing a runtime exception with I must fail message. So what I'm doing here is I'm starting the engine again. I'm selecting not the whole class, I'm just selecting the method inside the class, my test class. It means select method, demo test class, and then I need the name of the method. The bad thing here is it's not really refactoring safe because I have to deal with plain strings in the end. But well, just have it in mind, if you're declaring this one, make it refactoring safe declared in static fields so that you can reference it a few times. Then I'm executing exactly this tiny one test and just checking. Here, for example, I have one failed test. Yes, I just put one test in. And then I can say, please check if this one finished with an exception. Yes. The exception was of instance runtime exception. Yes. And then I can check if the method was something like, and here I'm just have the plain string that I'm using during the test declaration. So it makes sense not only to check the statistics, it makes sense to check the failed test and all this stuff very well, because how to deal with failed tests is a critical thing for custom test engines. How to start a test engine. After we know now how to test a test engine, it makes sense to understand how to ramp up the default test engine and then the own one. The test engine itself will discover the tests. So what is the amount of input or the amount of test cases for me? Then you have to prepare the launcher. You're creating the test plan itself. The test plan is a tree with information about in which order I should execute what type of text with and what is the input information I have for this test. After this, I can register a few listeners, for example, to create statistics, to collect runtime metrics, to collect whatever. So everything I can just grab during the execution of the test plan itself. Then I'm executing the launcher. I'm just saying go. And after this, I'm grabbing the result out of this engine and analyzing or dealing with the result itself. This is a little bit more source code. It means here I have this request. I'm building with selectors the amount of input tests. Here I'm using this reflection helper methods from the JUnit team itself. So it's a good advice to use this one and don't create this by yourself. It's there are a lot of work in this stuff, so don't do it by yourself again. Here I'm selecting a package. For example, my personal behavior is that I'm using as prefix JUnit dot and then original package name, so that, for example, some configurations are easier for me, but you will have your own naming schema. So select the packages or the class paths, whatever is the input, and then build the request itself. After this, create all the instance of the listeners you want to have. There is one default listener, for example, the summary generating listener. Yeah, use it or whatever. Don't use it if you don't need this overview. Then create the launcher config. You have this builder pattern here to create it. And here it's important that you are disabling a lot of automatic features, all this auto configuration, auto resolving and all this stuff, so that you have a very defined and clear, precise input of what you're doing. For example, here this test engine auto registration, just kill it so that not additional test engines are started. Then this auto registration for this execution listeners, just make sure that you are just dealing with your listeners you really want to have. And then you just need an instance of the test engine, and this is just done by new Jupyter test engine. That's it. Maybe your test engine will need some other init process, but a test engine itself is just an instance of a class in core JUnit5. And then adding the listeners, and then you have the configuration to deal with. After this, going to the factory, providing the config and creating the launcher itself. Then discover. So just see what is a test plan. The test plan is now something static. It's a tree of all this information with notes about what kind of test, in which order, and so on. Then you're executing both, and then you're consuming, for example, the summary. So this is just copy-paste code, so it's really recommended just do it in the same way and then maybe tweak it a little bit for your needs. But there is no support from the JUnit5 team so far to get rid of this boilerplate code, but here it is. So the basic structure of a test engine. Coming now to the test engine itself, what do you need? I want to show how to create the first or the minimum test engine itself. And what we want to do, we are not dealing with test discovery right now, so we are just declaring a test plan by ourselves to understand the structure. Then have in mind that the production code inside your project is the test engine itself, so don't put this one in the test source code path, put it in your production code path. Then the test code is the test for the test engine, for sure. And then we are testing our own tiny implementation with the Jupyter test engine. So to have access to this one or to the basic implementation so that you can deal with some basic implementations or support utilities, just add the JUnit platform engine inside your compile scope and the platform commons in your compile code as well in the scope compile. So now we have the basic functionality that we can use to build stuff on top of the platform and to build our own test engine. Yeah, and then we need some platform launcher. This one we need as well, and this in compile scope as well, because we want to write integration tests for our own test engine. So how to write the first own test engine. If I want to write a test engine, just implement test engine. That's it. You have to create a few, or you have to implement a few things. The first method is getID. GetID is just like an identifier. Make sure that you're not using the same ID for different test engines. That's it. So it's not a good idea to call your test engine Jupyter. The next one is a discovery method. The discovery method we will cover a little bit later. Here we are just creating one node because our test plan right now is just one node. There are no tests, no discovery. We will come back to this one later. But what you need is you have this engine descriptor. A descriptor is just one node in your test plan or one kind of node in your tree, and you have this engine ID as an identifier, and then the display name. This display name is just a logical name that you will see inside the log files or on command line output and all this stuff. Sometimes, yeah, well, just make sure that there's a nice name someone can understand. Then we have the read node. This is yeah, the return type from the discovery method, so to identify what is a whole test plan. And then we have the execution itself, and this is all. So the execution is just, you have now the engine, the instance of an engine, you have the execute this listeners, because during the execution plan you can just say listener A triggered, listener B triggered, and all this stuff. And then what you should do is just, before you're going from one level to the next level inside your execution plan, just say to this listener, for example, I start executing now this level, and after this one is done, I'm done with this, and this was a success, yes or no. So in total, you have this engine, you're grabbing all children you get from this one, and for every child, we are just invoking now for that listener, start it, stop it, say it is successful, and if you have done this for all children, say the whole plan is successful, executed. And that's it. So this one, what you see here with this going from one layer to the next one inside the tree, is more or less a basic behavior of a test engine. And then you have to say yes and no for every layer. I'm starting with my work now. The work is done and it was successful, yes or no. That is more or less a basic structure we have to follow. If you're doing this one, you will see output on command line. For example, we found one container. Yeah, we just started one. We started one. Yes, we have one successfully. Yeah, we just used always a successful method. And we have no test, we have no failed test, we have no and so on, because we just created a root node for the whole test plan. So from this one, the next question is how to activate this test engine. So, and how to declare test. So these two questions we have now. First of all, I want to see how to declare, or what is a possibility to declare a test. You have different ways of declaring a test, and it's really up to you how to do it. Here I'm showing you just how to do it inside the source code with annotations, but feel free and imagine that you can do everything. You can just go to one endpoint and just get a bunch of test instructions. So it could be a file, it could be a REST endpoint, it could be inside a database, it could be everything. So it's just one way of defining a test. And here I'm using just the traditional or the most common way to create an annotation to declare a test inside Java. Okay, what I want to do, I want to find all tests that are annotated with @nanotest, so my annotation. I want to execute all these discovered tests. The IDE should be already able to execute it with right-click and execute method, or execute and package and all this stuff. And with Maven, I want to do exactly the same. So I want to have Maven test, and it should execute all this stuff. If I have done this, I'm sure everything is fine for the beginning. So what I'm doing here is I'm creating an annotation. I have to define here if I can use it just on methods and or on classes. Here I'm just say I want to have something that I'm able to use only at method level. So I'm saying target is element type method. Then it must be available via runtime. So don't forget this one, otherwise it's just after compile not available. And then there is one thing, this @testable. And @testable is a hack. So I will come to this in a few seconds. And then I want to have one annotation for the test, and I want to have a different annotation on test class, on my test class. Why? Because then I can say on class level, I have the possibility for customizing with attribute A, B, C in my annotation, and on method level, just some other attributes or no attributes. It's just only to show that you can do it differently, and that's it. Okay. What is testable? Testable is a hack. So the JUnit5 team discussed, I think initially with IntelliJ people. I'm not sure, there's history, forget it. But right now it is @testable is here, and this is an annotation that could be on type or method level. It is available during runtime, and it's more or less a marker, because the IDE, what they are doing, they don't know if you're creating an annotation for called nanotest or whatever. So to have the whole functionality of the IDE, and this is a generic one, they are just searching for something that includes the annotation @testable. That's it. So don't forget it. If you're adding it and using it immediately, you have more or less 100% IDE support. Writing your own test engine or customizing this one. So I'm creating now my nano engine. It's implementing the test engine, and the ID is just a string. Here I'm lazy, I'm just using the simple name of the class. The next one, I need the possibility to decide if something is a test class, yes or no. And now it's important to know, what do you want to have? A test class, for example, here I say, I want to decide this is a test class if the method is, or the class is not abstract, it's not private, it must be annotated with nano test class, and if this one is successful, it is my test class, otherwise it's not a test class. So it means now you can start defining if you have special requirements to define this is a valid test class. Later we're doing the same with test method, and to make sure, for example, JUnit5, they are not dealing with return types in test methods. But if you want to make sure that your test is always returning some kind of summary instance, then you could just add it in this predicates we are using later during the discovery process. And then, you know, if I say this is a valid test class, I know there is a return type of class, whatever, type, whatever. Or I have a method signature with input param A, B, or C, whatever. So feel free to be creative and to define what really fits to your project. The same I'm doing with test method, for example. I say it's only a test method if it is not static, it's not private, it's not abstract, and I have no params. So if I have a param, I'm just ignoring with this test engine completely this test method. So even if there's this test annotation, nano test, but if there's param count higher than 0, I'm just ignoring it. So with this, you can just define the grammar of your test engine and the way how to describe tests. This is a very powerful thing. Do it carefully, because changes here means mostly changes in the whole code base. The discovery process. The discovery process is just going through all input classes you will get. And here it's I'm creating the engine descriptor, the root node of my test plan, and then you have this different selector. So if you're, for example, using the IDE, right-click on a package, it will create in the background some kind of selector. And this is different by IDEs. For example, IntelliJ, if I remember right, it's if you're going to a package, it's not giving you a package selector, it's using a class path selector with a filter of this package name. And Eclipse will do it differently, and Maven will do it maybe differently, and so on. So you really have to support all possibilities, and all possibilities is you will get something on class path within selector, you will get something on package level, on class level, or even on method level. Right click on method, execute. And these are the entry points, and from this you have just to think, if I'm starting from root, class root node, then I start going step by step down if I'm starting with package, and so on. So this is just a declaration, boilerplate code we need because there is no support so far from the JUnit5 team. If I want to append tests in root, there's the first method I'm showing here. It's just my selector gets a class path root. I have this one, I find all classes in this class path root, and here you see I'm using this predicate is test class. That's it. So what these service utilities are doing, they're going through the whole class path. One class after another will be provided, and then it will invoke the is class, or this predicate you're just providing. And if this is successful, you will have the class itself. It's filtered, you have just the class that are matching to this predicate is test class, and then you can append this one to your test plan. So, and this append is something you should think about, what kind of information at this level you have and you want to provide later during the execution of your test plan. And the information you're grabbing here, it could be a request somewhere, it could be some static information, whatever, completely free, what you want to have. But in the end, you need the class itself, because this one you need later for invocation and all this stuff. And then you're wrapping all this in some kind of descriptor, and the descriptor is just an extension of the basic descriptors, and then you can add all the attributes you want to hold, and this will then add it to this test plan. And the same with add append in test method. So if you identify it is a test method, then you're just grabbing all the information for test methods. I created here this descriptor node for especially for methods, and then put all the information as attribute inside so that this is available during execution, because all nodes in this tree will be delivered step by step, and in the end you have to deal with all the information that are available inside this test method descriptor. Okay, all in package. Here I can just say, please use the JUnit5 reflection utils. They are quite good and they found a lot of bugs and it's more or less battle proofed. So use this one, so this reflection support, and then all the static method. Just have a look there. They are providing really a lot of stuff. And here, for example, everything in a package, I just say check my class and then go to every class and add this one. Okay. So if I, what's the test plan? So if I'm doing all this stuff, I have a tree, not a graph, a tree. And this is built on the base of test descriptors. A test descriptor is a node inside the test plan, as I mentioned earlier. A node can be a container and a test. So the container for a class is a container, mostly because you have inside test methods. If you have a node for a package, it is a container. And the node for a test would be a test. But the tricky thing here is a node can be a container and a test at the same time. Why? I'm not really sure. But normally the test itself is the last point in your tree, the leaf. And the container could be both. So the last thing could be a container as well. So just have it in mind so that you're not losing this one. And a good thing is don't start from scratch from the interfaces they're providing. Start with abstract test descriptor and just using this one as a basic reference implementation to extend this one. Okay, so a test descriptor extending the abstract test descriptor, and here you just have to deal. If it is a container, you have to have the possibility to add children, and if you are just a test, mostly you don't need this one, and then just going recursive. Here what I'm doing, if there's an invocation of this container instance, this test class or class test descriptor, I'm grabbing all the information from the class itself, and then I start going over all declared methods and creating the child nodes for this one and adding this one. Yeah, that's it. And it's of type container. Okay, for the method, it's the same. I'm just holding the method reference, I'm holding the class, so that later I'm able to invoke this stuff, because what I have is just class and method and all this stuff, and then I have to invoke what. If you're building your test plan completely independent from some input sources like test file, database, whatever, maybe you have just different informations you need. If you're going here just over plain Java, you need something you can invoke later. Okay. So then the execution. The execution is more or less, you will get some kind of node, and then you have to decide what type of node this one is. And in the moment we have three types. We have the engine descriptor, the root node, we have something on class level, and we have something on method level. If it is an engine, a container one, I'm just start executing a container. Same with the test class, I'm just executing the container. And if I'm finally on method level, I'm executing a method. So it's just recursive down and it's boilerplate code, and there's no other implementation for this. So you have to write all this stuff by yourself. So executing a container is just have in mind. So you have to say, I'm starting the execution, I'm executing, and I'm done with the execution. And exactly this is what we're doing here. We're executing this one, saying, okay, I'm this root node, I will start now. Then I'm going to all children recursively executing this one. And if this is returning back, I'm just saying I'm done, and depending on the result I say this is successful, yes or no. A method is the same. I just say now I will start executing the method, then I'm executing the method, and then I'm saying I'm done with the method, positive or negative. And now we are coming to the test method itself. It means in this case, I have just a class and the method, so it means I'm creating a new instance. Here you can do everything. You can use CDI, you can whatever you want. You're creating an instance, Then I'm saying, okay, I'm invoking the method here. I'm just using the reflect utils as well. And if you have params, you have to make sure that you're creating the parent instance or the parameter instance by yourself, or just getting by CDI or whatever, and using this for the invocation of the method as well. If everything is good, successful is the return. If it is bad, failed is the result. That's it. So now what we have done is we just went through the whole tree. Here the test engine, just as an overview, of the predicate. This is a test class, this is a test method, and then I'm just discovering everything. So go to whatever selector I'm getting and analyzing all classes and building up the whole tree, the test plan. And after this, I'm just executing here, request get my root node and start executing. So this one is quite easy and straightforward. The main thing is you have to do it by yourself because this one is not provided. One thing here is that you can use service locator here and how to activate this test engine. You have to go to resources, meta and services, and using org.junit.platform.engine.testengine, and in this file you just full qualified names, adding all test engines you want to execute. That's it. And then you can start writing tests like this one. Add nano test class and inside nano test. Now you can start using your IDE with right click and ramping up, ramping down this stuff and executing and so on. Okay, now we know how to create a custom test engine. It is time to think a little bit about the ideas. What can you do with all this, what you saw? For example, you can add a license checker inside your custom test engine. So if you want to create a commercial product and you want to deal with license, or do you have to deal with license? For example, you're using some professional tooling with support or with a license included, and you need to activate this license for every test run, or you have to connect to services with credentials, all this stuff. This could be done inside the test engine to make sure that this is done right. For example, if it is a paid service you are consuming, that you are adding a circuit breaker, that if the frequency is too high, or you have identified a loop of requests, that you are just breaking it. The next idea is you can use the test engine to collect metrics about the execution order, success rates over different test engine instances and all this stuff. So storing these metrics in a centralized repository could be one thing you can need. The next thing is authentication and authorization. For example, if you have different resources to connect through, then you can do all this handshake inside your test engine, so that this implementation is in one central place and maintained. One very interesting thing is the way how to describe a text. So we saw how to describe tests for the Jupyter engine, because we want to use this test engine to test our own custom test engine. But think about what domain specific things you could need to make it easier to describe tests for your domain. So it could be that, for example, you want to have an explicit return type in your test methods. It could be that you need some special input params. It could be that you have a different way of describing variants of a test. So it could be loading test definitions from an external resource. It could be a handshake with some other infrastructure parts, whatever is needed. So whatever you need to describe in a very efficient way your test, it could be a domain specific test specification or test description, and with a custom test engine you can it's a DSL for tests. One thing that quite often leads to complex and fragile implementations with core test engine, the Jupyter test engine, is that if you have to deal with complex life cycles, for example, my experience with testing web apps was not so pleasant, because I want to ramp up a servlet container, but I don't want to ramp it just for every test. Sometimes I want to ramp it up for every test. Sometimes I want to ramp it up for every test class or package or some kind of test. For example, if I want to check for memory leaks and I have a bunch of tests, I want to ramp up the servlet container just once. If it is a very slow init with database and all this stuff, I want to create this instance just for the whole test plan once. If it is a very fast component test of web components or whatever, I just ramping up every time a fresh browser, or I have a different variation of browsers I want to test. So all this stuff is more or less some technical things around the test. It has nothing to do with the test description itself, but it's time consuming. And if you're dealing with a regular way of ramping up, ramping down infrastructure, this is quite a complex task with extensions and all this. So for this, custom test engine is a very, very good thing. One thing is, if you want to support different test techniques, it could be that you really want to have random test execution with some statistical behavior. If you want to have something like mutation testing, if you want to have some other test techniques, then it makes sense to integrate this one in a custom test engine. If you are not able to find some plugin that's already existing. There are some custom test engines available, but sometimes they're using their own way of describing tests. And if you want to have a connection, or if you have one way of describing tests, sometimes you have to integrate these techniques so that this fits to your domain-specific test definition. We had a few moments speaking about persistence and immutable test plans. So if you're creating a test plan and you want to store this one with additional information, with timestamps, with checksums, whatever you need here, this is a good thing. And the whole handling, for example, pushing this immutable test plan to an Artifactory repository with a version, with a test run number, with a user, whatever you need. So you can just create this test execution plan and can push it to a generic repository and use this one later. Test execution priorities. If you have very long running tests, it makes sense sometimes to play around with priorities. For example, you have a long test that's running with compatibility modes, and then you want to do some additional stuff. It could run here some kind of test with a lower priority, and if you're doing some additional tests, it's just hooking in with some small tests in between. So sometimes you can use this one, or it makes sense. But if you want to scale horizontally, you have different possibilities. Mostly test engines just supporting the concurrent execution inside your own machine. So if you have 4 cores, then it's different to the point if you have 20 cores. Well, most developers are working on a laptop, and then the amount of cores is not so high. And if you really want to scale up, and for example, if you have this long running or resource intensive tests for web tests or for database driven tests or whatever, or mutation testing is a very CPU intensive thing. But the good thing is, for example, for mutation testing, it could be distributed on an atomic, or every test or test mutation is atomic, so you can really run them independently. Whatever the case is, how to split up this in atomic portions, what you can do is you can run it from IDE, Maven, CI, environment, whatever. You're creating this test plan, or this test plan is already generated somehow and you want to replay it, so you're grabbing it from repository. And then let's assume here I'm using a test class as a container and a test method for the test itself. Then I would have some split up, like one class will contain multiple tests from 1 up to n. And if I'm just using one class, so I have a bunch of test methods, I could distribute this one to different nodes. So I've done some very cool proof of concepts with these. So for example, I have built a distributed test execution engine based on Hazel cars. It's a proof of concept, so not all security aspects are covered here, but what I've done is I had a few big machines. I built up a Hazel cars cluster on top of it, and then on my laptop I just wrote my test. My test engine was ramping up, connecting to this Hazel cars cluster, pushing the modified classes to this class loading environment inside my Hazel cars cluster, and then executing every single test class inside different nodes. So in total I had 3 machines, and I sometimes with long-running tests, for example this web testing stuff I've done during this time, I was able to have a speed up nearly to the factor of 3. So the overhead of ramping up a test of the Hazel cars was just I think 100 milliseconds, 200 milliseconds. So if the test itself it's running 5 seconds or 10 seconds, it's maybe a good idea to just invest once this 100 milliseconds in the beginning, and then executing the tests on different machines. So this is quite an interesting thing for scaling horizontally if you have huge test plans, or if you have infrastructure you want to share between different developers. So if you want to know more about it, just ping me, and I would really like to work with someone more on this topic. It's a private interest, to say the truth. Security payload generation. So if you're talking about SecOps or security stuff, it makes sense to think about how you can use security payloads and this generated injections. So the basic idea is you're loading, for example, a test plan, or you're generating a test plan, and then some methods are marked with this is a candidate for security payload. For example, everything that's collecting data that's coming from UI or whatever. And then what you can do is you can generate the security payloads with a version and store them in generic Artifactory repository, so that this is available, and a reference so that you're using the same security payloads on CI environment as well as on your laptop. And then during the test run, it's connecting, checking if there's a new version of the security payload, loading the security payload. It's caching locally, for example, if you want, and then just injecting the security payloads to check if you have some risks or not, or if you're covering all stuff you know or you have experience with. So in total, it's more or less you have a repository for the security payloads, maybe for the security plan as well, or your test plan. You're generating this stuff. After this one, you're pushing the build information and the test plan with the information which version of security payload you used back as build information to the repository for later reproducibility. And then you're running the test, and the result is going back to the repository as well as part of the build information. So have in mind that you can do a lot of stuff with this to harden your application if you are running stuff in the cloud. Well, the main thing how this could be integrated is you have the repositories in Artifactory. So you have different kind of repositories, and you can build for every stage a different repository. It's very lightweight, this approach here, so that this information is isolated. And then, for example, you can combine it with X-ray to scan even the dependencies that are using this other way around. So you have a test. This test is using dependencies. You can check in the same way with the X-ray, for example, if you have different kind of security issues, and if you have the security issue in your dependency and there's not a new version available, or you're just stuck to this version, whatever point it's for this, you can say, okay, if I have this kind of vulnerability, then I can just use this security payload to verify it if we are covering this one around this implementation, whatever. So you can combine this technique so that it's not only the security payload, but you're checking the dependencies and later the Docker images and the runtime environment and all this stuff. So if you want to try it out, I show you here the URL. Just go to jfrog.com, start a trial. I think in the cloud it will take approximately 10 or 15 minutes, and you have the whole infrastructure for some days. I don't know how long the trial is right now, but the same you can do on-prem if you prefer this one. So everything is available on-prem or software as a service or on a hybrid mode. It's really up to you. So try it and play around with the security payloads. This I really would recommend. It's a very interesting field of testing. Okay, that's it. So first of all, thank you that you attend this talk here. And if you want to reach out to me, Twitter is the best way. So just ping me via Twitter, send me a message. I'm really interested in having a discussion with you about your ideas and your experience about this one, because this is a broad topic and I'm really eager to learn more about this one. And this, yeah, well, just you're invited for feedback and have fun. Try it. See you.